From adaptive clearing, I'm actually going to use a faster trick to be able to program my next toolpath. I could come up to the 2D toolpaths panel and select 2D contour. What I'm actually going to do is I'm going to right click on the adaptive toolpath because I'm going to use most of the things within adaptive, which are the geometry selections as well as the tool itself. I just want to create what's called a derived operation. This is going to have all the clearances, the depths, and everything else automatically transferred over to another type of toolpath, which I'm going to select 2D milling. As the arrows drop down, you'll see I can just navigate through them, and I'm going to go 2D contour. Now I've successfully taken my cutter, added it to a new 2D toolpath into the contour toolpath, and you'll see that my heights are the same. We're going minus 0.05 millimeters from the bottom, and then our contours are selected. Now I'm going to turn stock contours off because that stock is no longer there. It's been cleared away by my roughing strategy, my adaptive clearing. And then I'm also going to control and left click that inner circle because I want to select and use a separate toolpath to machine that. Basically what I want to do with this is just machine this outside profile. So with stock contours turned off, you saw that truncated itself down. Tabs is another method that allows you to tab machine and leave specific portions of a contour intact to be able to break away the cut if you need to. Rest machining will only machine what's left over. This is a pocketing routine. And again, tool orientation. Now you'll see here within the geometry tab I have tangential extension. What this does is this adds length to my cut. Now if this were a single chained contour, I would just be able to go ahead and add the amount that I want to travel past that geometry, and then I can separate that and have them two different lead in, lead out basically amounts added to the geometry. Now this is separate from lead in, lead out, but this would be if this were a cleanup on this face of this edge. I could actually shorten this toolpath or lengthen the toolpath as I need it to just cut that geometry and maybe blend to a surface. This is an important thing to know. I'm going to leave this at 0 for now. My heights are going to stay the same. My technology has changed, however. Now this is important to note that now everything for the technology is set up for contouring. Now by default it's set up with a lot of things that we won't need since we're only going to be creating a finish pass with this toolpath, but the basics are still there. Within our passes panel here of this dialog box, you can see that I have my compensation control. This is an important thing to know. You're usually going to be doing climb cutting. And this is how we set up our cutter compensation for the toolpath. Now if I hit off, that's going to mean that it's going to try and travel the center point of the cutter on the selected geometry. If I have in control and where, that's going to give us the ability to use G41 cutter compensation. So those are the two functions that you want to use to be able to enact the cutter radius compensation on your finish pass to be able to hit the particular GD&T that's necessary for the part and control the tolerances out at the machine tool itself. I'm going to leave the compensation allowance to the default. That's just basically a parameter specific setting. We're going to turn off make sharp corners as this is more of a round part. I'm not going to have multiple finish passes, but this would allow me to add another finish pass to it, and therefore it would travel 0.127 millimeters twice and do 2 cuts. I can control the feed rate and change my feed rate based off of just the finish pass. That becomes more necessary with titaniums and stainlesses. We're going to roll around corners. We're going to keep that. If this were sharp corners, it would actually try to roll around them at a default of, say, 3 to 5 thousandths. The order in which it's going to cut, if I had multiple selections, this would allow it to either machine it in the fastest order necessary or preserve the order that I picked it. Both ways gives us the ability to machine back and forth. This isn't necessary with a finish pass. Roughing passes, we're going to turn that off. And we're also going to turn off multiple depths. This is again just a finish pass. Within the linking, you can see that it's mostly stayed the same. The difference is now ramping instead of being a selection for getting into the roughing of something. This is going to be a ramping of the entire toolpath. This would be a continuous ramp down the entire profile. I'm not going to do that for this finish. In my lead in, lead out, you can see I now have the capability to control the horizontal lead in radius as well as the angle that it's going to engage. And then finally the linear distance. Now this linear distance is important because this is what is going to allow cutter compensation to engage on stuff, on particular controls such as Fanuc, things like that. You always want to have a value within this field. The vertical lead-in radius may be set again to a default. I don't remember if it's 5 millimeters or not, but I always zero this out and I will make this default. Now here's a trick external to making it default for just the contour toolpath. If I right click on this field, again I have that edit expression, but above that I have the make all default. Now if I click that, it's going to make that all default for anything within this vertical lead-in radius field. And my hopes is that I won't have to continually making this 0 over and over again and having a vertical radius where I don't want it. Now, entry position. The cool thing about HSM is that it actually gives you the ability to click on entry position and click somewhere within the geometry and put a point for the toolpath to enter. I'm going to hit red X this, I'm going to hit OK and let this toolpath calculate. Now, by default, it's going to pick the most logical point of entry based off of a few known things, the last point of the toolpath before it, and the geometry. Now let's say I wanted to start this on the opposite side. So what I would do is I'm going to double click on the toolpath, go to my linking tab, scroll all the way down to the entry position option. I'm going to left click on this option and I'm going to click this opposite corner. Maybe even let's click the midpoint. I'm going to select OK. Now that will automatically change that, and it's that easy to change where I want my toolpath to start.